for our training on our HMH7. Now let me go ahead and share my screen. And we'll get this up and going here in just about 2 seconds or so. All right, fellas, we want to make sure that you guys can see the screen okay.
Yes, sir.
Can you see that okay? All right, let's go and get the slideshow up then. Okay, so you guys should be able to see the front screen okay. A picture of both the 2-fan as well as the single fan model. Can you see that okay?
Yes, sir.
All right, well, fellas, good morning. We're going to go ahead and talk about the HMH7 horizontal heat pump again today. And we're going to ask that you please remember that you always have to have those fittings, those special fittings that are 5/16 flare to a 1/4-inch flare. And what that does is it allows you to hook your service hoses up to these things. Now, Daniel, I don't know if you guys carry those at your location, but it's something you definitely want to consider having some of those, because for the guys to get their service hoses on those, they're going to need those. And so make sure you mention that during the training or whenever you have opportunity to talk about the unit, make sure you've got some of those fittings. In addition, I always like to kind of kick off our training a little bit with some minimum and maximum air temperatures. You'll see that on the slide right here. Minimum is 35 degrees cooling and -5 in the heating mode of operations, which is pretty remarkable for a unit right out of the box. And then your maximum outdoor temp is going to be 122 for cooling, and then 75 degrees for heating. Now, normally you wouldn't see people heating at 75 degrees, but it's nice to know the system does have that capability. If you've got a special situation, where the homeowner wants to heat the home inside, even when it's 75 degrees outside. So you have quite a broad range there on the HMH7 as far as capacities. All right, so team, this morning at this time, we're going to be actually talking about some low voltage wiring and the setup of the JHVT air handler along with the HMH7 heat pump. So the first thing we're going to do, we're going to talk about how to set up and to review on the control board. There's actually a dip switch there, or a selection that's going to give you either AC or heat pump. It's really, really important that we select HP off the control board, and we'll show you where those switches are here in just a second or two. We're also going to discuss a low voltage block wiring diagram, as well as the S1 circuit for reduced airflow command. Now remember, this unit does not require, let me say this one more time, this unit does not require a relay kit. And I'm also going to go ahead, because it helps stream a little bit better, I'm going to go ahead and shut my camera off at this time as well, because it does stream a little bit better whenever I'm have my own camera off. In addition, we want to make sure that we understand that not only do we not have to use a relay kit, but we also want to make sure we do have to have a thermostat that has a BO selection for reversing valve operation. Now, while we're talking about thermostats, I don't have it on the PowerPoint here, but let's make sure that we stress too that whatever thermostat that we select, we want to make sure we have the OB or the BO selection on there. But we also want to make sure we run a hard common wire to the thermostat. We don't want a thermostat that has a power stealing thermostat feature or a power stealing feature. I know some of your Nest and some of your ecobee thermostats, if you have the capability of pulling that common wire, you got to be sure and pull that common wire, because if you don't and you have a power stealing setup, what can happen is the thermostat can actually cause some erroneous codes to be thrown on the board outside. So be sure and pull that hard common wire all the way through. In addition, one other little tidbit to please remember is, because you're not using the relay kit with the JHVT air handler, the contractor is going to have to provide a field installed biflow filter dryer on the liquid line. So just please remember that if you're not using that little 001 kit like we do on the other product, they're going to have to provide a field installed filter dryer. Any questions or comments on that so far on our little agenda this morning? Everybody good? All right. Okay. All right, as we take a look at our the airflow configuration and the setting, the airflow configuration and the system setup dip switches, you're going to notice that on the control board itself, there's going to be some bank of dip switches. You're going to have some airflow configuration. You're going to have some system setup configuration. You're going to have some different things on there. But specifically, we're going to drill into one particular dip switch this morning that we want to, excuse me, we want to talk about specifically. And what that is, it's that AC/heat pump switch, that AC/heat pump switch. Now you're going to notice on the control board that AC heat pump switch must be set to the HP position. This is important because what's going to happen when you have an S1 input on the board, it's going to look at that board, that dip switch, and to make sure that it's on a heat pump. And so you want to make sure that on the control board itself, you're actually setting up the air handler to know it's looking for a heat pump. Then with an S1 input or an S1 configuration on the board, that BO selection or that BO input from the thermostat becomes a heating call. So let me stress this one more time, that AC/heat pump switch has to be in the HP or heat pump position. Now you're going to notice here's a little bit more of an explanation as well. That switch actually configures the control board to operate correctly with an air conditioner when it's in the on position or the heat pump when it's in the down or off position. Now with the switch in the on position, what's going to happen is, let's say you're on a straight cooling unit. If it's in the on position, the control will treat any Y call as strictly a cooling call. However, with the switch in the off position, a Y call is treated as a heat pump heating call unless you have a BO for cooling reversing valve. So what I'm trying to say, on just a regular heat pump, just a plain Jane heat pump, that BO, when that HP switch is in the heat pump position, and on a regular heat pump, you get a Y call, it's a heating call. But if you have an OB selection with that, it becomes a cooling call on a regular heat pump. Now watch this. With that switch in the HP position, when it's on the HP position, if the control is set up for that S1 input, what you're telling the board at that point, you're telling the board, hey, I'm on an HMH7 outside, and now we're going to treat a Y call with an OB signal as a heating call. So it's exactly opposite of a regular heat pump. But I wanted to stress that whole scenario again. So in summary, one more time, if that switch is in the on position, you get a Y call. It says, oh, I'm in the cooling mode. If that switch is in the HP or off heat pump position on a regular heat pump with this air handler, I get a Y call. It's a heating call. Unless I have a BO input, then it becomes a cooling call on a regular heat pump. But now hang on a second. The HMH7 is a different, we energize the reversing valve in the heating mode, so we're able to deal with that as well. So now with that in the HP position on the switch and on the HMH7 outside, when we have a Y call, it's a heating call, just like any other heat pump. Excuse me, it's a Y call is a cooling call, like it'd be like a cooling unit, but it's going to be on the HMH7, it's going to be a cooling call. But if you put a BO with the HMH7, it becomes a heating call. So this is really important because the whole point of this lesson right here is that if you're set up with an S1 input, and that heat pump switch is in the heat pump position, it knows it's on an HMH7, and now it's going to treat that OB signal from the thermostat as a heating call on the HMH7. Any questions or comments on that? Like I said, we got to really wrap our noodle around that. So there's a couple things the contractor is going to have to do when they set this air handler up. It has to have the HP switch in the heat pump position. They're going to have to they're going to have to configure the board for that S1 input. And then the whole lesson for all of this is the fact this air handler does not require any kind of relay kit, but we've got to set it up on the board to make sure that it knows it's looking at the HMH7. Or if you put it on a regular heat pump, you got to let it know it's on a regular heat pump as well. So any questions or comments on that before we jump into the block wiring diagram? Good shape? All right. Okay, let's go ahead and take a look at this block wiring diagram. So there's that OB signal. And we're going to, again, it's going to be going to the B terminal outside. So OB to B to OB and then to B outside. And what that is, that's a reversing valve operation in the heating mode of operation. So remember that thermostat has to have that BO selection because we're going to energize the B terminal or the BO terminal on the heat pump thermostat for heating, reversing valve for heating. Very, very important. After that, it's pretty straightforward. W2 is our second stage auxiliary heat. W1 is our first stage auxiliary heat, and we're going to carry that all the way outside because remember, we want to bring on one stage of heat strip. Anytime we go into defrost from that, we get a W signal from outside to bring the heat strip on during defrost so we don't freeze the homeowner out. Now watch this, Y1 from the thermostat, this is really important, Y1 from the thermostat goes over to the Y/Y2 on the terminal board on the air handler. And the reason we do that, we want to make sure that anytime we have a Y call to the compressor outside, we're going to drive the indoor unit to 100% airflow as the default airflow. So that goes to Y/Y2 on the air handler. C terminal goes all the way through. And please remember one more time that C terminal going all the way through is a hard wire. We want to make sure we've got that hard wired common terminal going all the way through. Ours 24 volt hot, it's going to go to the thermostat to the indoor unit, but it does not go outside. That's important to remember that. And then the G terminal is your fan call going, G to G. Now you're going to notice something. Y1 terminal on the air handler is not used at all. But we are going to take that S1 from the terminal board on the air handler and take it outside to S1. So we don't have a relay kit, but we do have an S1 terminal on that board that's going to go outside. Now, be sure and look at the install information because the install guide, I think it's on page 13, but you can double check on that. But if you take a look at the install guide, it's very, very clear on how to set up that S1 input. So one more time, the S1 input is a direct input from the outdoor unit to the indoor unit on the JHVT air handler for airflow reduction. You do not need that relay kit. However, we have to make sure we set it up like we talked about in the previous slide. The HP switch has to be in the AC HP switch has to be in the heat pump position. We've got to set the control board up to look at the S1 input. That's a little step you have to do in the install guide to set the board up to look for S1. And then you take that S1 wire from the outdoor unit right to the board on the JHVT air handler. And so once you get all that set up, you've eliminated that relay altogether, that relay kit altogether, but the contractor still has to provide that liquid line bi-flow filter dryer. So any questions or comments, Daniel, on this stuff we're looking at right here? Any questions or comments?
No, sir, I don't believe so.
Okay. Well, fantastic. Well, let's go ahead and take a look then, just a little animation. Let me back up one more time. So whenever the outdoor unit is calling for reduced airflow, it's going to energize that S1. You'll see that animation there. It energizes the S1 and it calls for airflow reduction directly onto the air handler itself. That's pretty cool the way that works. Finally, one other thing we always want to make very, very sure that we stress whenever we're talking to our contractors is please remember on every install to confirm proper airflow. Now, remember the HMH7 is a modulating unit and nominal airflow is going to be critical. So be sure and size that ductwork to provide 400 CFM per ton of cooling capacity. And that's just good practice anyway for your duct sizing. But let's make sure we've got proper sized ductwork on these HMH7s for them to work properly. And then another thing we always want to make sure as far as the airflow is concerned, Daniel, is we want to get in there and take a look at our velocities. And so even though we can have CFM, we want to make sure that we're pushing that air through the ductwork and through the duct components at the proper velocity. To give an example, on a main trunk, Manual D recommends 700 feet a minute velocity, and that's where I normally design my ductwork on my main trunks. And then my branch runs, I design them for 600 CFM, or excuse me, feet per minute. All of our registers and grills are going to be supplies at 500 feet a minute. Supply is recommended, and on return grills, 400 feet a minute on the return registers and supply registers. And then return grills are going to be about the same as far as if you don't have a filter in it, diffusers are going to be running, right about the same feet per minute. Now, this is really, really important. Can't stress this enough. If you've got a filter grill, if you've got a return grill with a filter in it, you're going to want to make sure and size that filter grill no more than 300 feet a minute velocity. So we slow the air down quite a bit from 500 feet to 300 feet a minute velocity if we have a filter in that return grill. So this becomes really important, especially if you've got applications where maybe you've got a home, maybe it's a 3-ton unit in this home that's got just one large return in the hallway or something like that. And the homeowner maybe wants to put a hardware store or big box store, one of those pleated filters that you buy, from one of the, hardware stores or whatever, that very, very restrictive. So we want to make sure that we do not exceed 300 feet a minute velocity across our filter grills if we have a return grill with a filter in. So these are important airflow considerations we have to think about whenever we install these units, especially on a modulating system like an HMH7, because what's going to happen if it has reduced airflow inside, or you don't have proper sized ductwork, what's going to happen, that unit's going to modulate back because it's going to see a colder evaporator coil, if that makes sense. And so we just want to make sure that we have a proper sized ductwork and we've got the proper size return grills and so on. Does that make sense? All right. Well, that pretty much concludes it. Let me go ahead and turn my mic back on, or turn my camera back on. And we'll go ahead and open that floor up if we have any final questions or comments on our little training this morning. Okay. So Daniel, let's go ahead and open the floor up. I'm going to go ahead and stop the recording at this time, then we can discuss any other things we want. Is there any questions or comments on the training before I stop the recording?
Let me just get clarification on SW2, the model configuration.
Okay.
That is not supposed to be touched, right? It's supposed to become pre-programmed from the factory. Is that correct?
As far as the outdoor unit?
The indoor unit, the air handler.
Okay, no, that's a good question. So the air handler, you may have say a 3-ton air handler. I'm just making that up, a JHVT 3-ton air handler. Now that air handler is going to be set up from the factory. It's going to be set up for the maximum airflow that thing's going to push. So if it's capable of pushing 3 tons of airflow at 0.5 inches of static, typically is where our testing points are, then it'll be set up for that. However, based on the size of the unit that you've got it hooked up with, and based on your ductwork, you may have to go in, and you probably will have to go in and commission that air handler to blow the proper airflow. To give an example, we always set our air handlers up typically to the maximum airflow they'll push, because we have no idea what ductwork you're going to put it on. So that 3-ton air handler, if it's capable of pushing 3.5 tons of airflow, it's probably going to be set on 3.5 tons of airflow from the factory. So it's a good idea to go in and make sure that you have your airflow configuration set up exactly where you want it, that you've got your your cool delay, and that cool ramping operation and so on, depending on your geography. Got a lot of humidity in your area, so you probably want to put it on that humidity mode, or that mode where it's got that cooling on delay ramp. And then of course your heat strip size too, based on the heat strip size you have, you're going to have to go in there and tell the air handler what size heat strips you have. So there is definitely going to be some setup with it, and that's all very, very well explained in the install guide. As a matter of fact, what I'd recommend you do is do exactly like I did. I went out and actually started reading through the install manual, and I think I even printed it down on the JHVT when I started studying it up and figuring out, how to set up that S1 circuit and all that stuff. So if you're going to be hooking up to an HMH7 outside, you're going to have to configure it. You're going to configure the board to look for that S1 input like we talked about. And it's really simple. Basically, what you do is you shut the power off and you put there's no thermostat wires hooked up now. You shut the power off and you take a hard jumper between R and S1 input on the board, turn the power back on, and then it'll give you some code on the little interface, and then you hold this button down for like 6 to 8 seconds, I think. And then it'll pop up and it'll say S1. It'll do some things. It'll say S1. And once you see that, then you shut the power back off. You remove that jumper, and then when you wire everything up and you turn the power on, the air handler automatically looks for that S1 input for a reduction of airflow. And so what that does is it totally eliminates the need for that relay pack, that you have on the other air handlers and the furnaces, that relay pack. Good question. Good. Any other good questions or comments?
I don't believe so.
All right. Well, I'll tell you what, then I'm going to go ahead and stop our recording. And thank you for training with me this morning. I appreciate it. But let me go ahead and stop that recording at this time. And so just because we stopped the recording doesn't mean